Hi everyone, David from Aberlink here. In this video I'm going to show you how to get started with offline programming. This will cover the initial setup. I'm going to do a completely fresh install on my workstation that you can see behind me. The key things on your end, you need to make sure you have a laptop or PC that is capable of running at least Windows 11 Pro. You need to make sure you have your offline programming key lock. So this is the license key that comes with the purchase of the software or with the machine order when the machine arrived. It's usually in this little silver tin, so just make sure you have that plugged in and ready to go. I'd also recommend having a dual monitor set up as I have with my workstation, but it isn't critical. You can do this on a single monitor. So before we can get started with offline programming, we need a copy of the latest version of Aberlink3D. This can easily be downloaded from the website, so using your web browser, in this example I'm using Edge, go to aberlink.com, click on support, then go to downloads. Over time the version numbers will be changed as the software is updated on the website, but we are looking for the Diva install package. So currently, as this video is shot, we are on 4.22.11.3 and we are looking for this one, Diva. So click download. That will then go to your downloads folder. Now some browsers, in this case I'm using Edge, but I think most browsers don't want you to download a MSI or exe file without giving a warning. So that's what this warning is at the top of the screen. So if you just click the three dots and say keep, and then the message comes up. If you just click show more, keep anyway, that will then continue on to download. Once downloaded, go to your downloads folder. So I can access it from here. And this is the download file here. And it's just a case of double clicking this to run the installer. So we're going to click next, next, and then install. That will run the install. And then we click finish, and that is us now complete. We have successfully installed the software and we are ready to get started. Now the software is downloaded and installed, you should see the two Aberlink icons on your desktop. This is the white icon, Aberlink3D V4, and the blue icon, Aberlink3D Offline. It's important when programming offline to only use the blue icon. So make sure your key lock is plugged into your laptop or PC, otherwise the software will not allow you to take any points. And with the key lock plugged in, you are ready to then double click the blue offline icon to start up the software. The software will run through some checks and then open up full screen. There we go. Now it's worth noting when you install this fresh for the first time, it uses default settings. So the screen or the software may not look like it is on your CMM, but we're going to go through some simple config setups now. So firstly, you'll notice that all toolbars are at the top of the screen. To align the toolbars, you simply click on the toolbar that you want to align, right click anywhere on the toolbar, and then select the alignment. So if I select left with the measure toolbar, which is quite a common setup on most CMMs, you'll see it locates on the left hand side. You can do this for any toolbars and you can have it customized for your specific programming station. The next thing you'll want to do is go to settings, click on the gear icon, and then adjust your units. So these are the default tolerances, round nominals, etc. And you'll also want to go into display and set up your display settings. I prefer to have 0 grid lines on the screen, so I'm going to change this to 0. And I also am operating on a bigger monitor, so I'm going to change the display font to 12. But you can customize these however you want. When finished, hit the apply changes icon in the top right hand corner. Then click the green tick to accept those, and you are now ready to boot up the CAD software and start programming. We now need to open the CAD software. To do this, you need to click on the Enable CAD icon within the Measure toolbar. The icon itself is an image of the small Aberlink test block, and if we click on this, it will open the CAD software. The CAD software initially is its own window. As mentioned earlier in the video, it's useful to have two monitors. You can place the CAD software on one monitor where you can be probing the part, and then the standard Aberlink software will run on the other monitor. However, if you don't have dual monitors, you're working on a single screen or a laptop, you can have everything housed within the same screen via the dock button within the CAD window itself. So within the CAD window, top right hand corner, if we select dock, that will dock the CAD image down into the bottom left hand corner, and the toolbar now combines with the standard Aberlink screen. So we have a CAD toolbar with all the tools available. So that is how we open and get started with the CAD software. The Probe Manager in the offline software works completely differently to the Probe Manager on the CMM. So it's important to note, when programming offline, we need to switch our probe on, click on the same icon that matches up with the CMM, only this time it is called Manage Offline Probes, and that will open up the CAD Probe Manager. Now I would highly recommend exporting your probe list directly from your CMM and utilizing the import function here. That will then generate the entire list directly from your CMM. However, it's very easy to add probes within the CAD Probe Manager. This is done via the blue plus symbol, and it's a simple case of selecting your parameters to match the probe that you wish to use for your program. We have the probe type, so touch, scanning, head touch or camera. If it's a star probe, we can tick this checkbox here where it says star. We then put our stylus diameter in, so if I'm using a 4 by 20, I'll then have the option to put a index in or a B index in, and I can even type out other components, so 20mm extension, TP20 standard force. The reason for doing this is if you don't bring in your probe list directly from the CMM, you need to make sure you know which probes to map over when it gets to the CMM, as the probe names won't be the same, so the probe won't allow the program to run in Aberlink on the CMM unless the probes match up. That is where we have to use Probe Mapper, which I'm going to cover later in this video. So yes, we have the option to add individual probes manually, like so, or we can import a list that we have exported from the CMM. So I have an example from the Axiom 2 in the demo room. So if I double click that, it's going to pull in all the data for all the CMM probes on the Axiom 2. All I need to do then to change between them is just right click, select Make Current, or alternatively, if you hit the green tick and come out of CAD Probe Manager, we can use the drop down list by the left hand side on the measure toolbar. So that is the Probe Manager. Before you start programming in CAD, I would also recommend going to the Settings tab and making sure that Stored Points and Feature Predict are both turned on. The reason for this is the CAD software becomes far more efficient when it can use Stored Points and Feature Predict. This is things like generating auto planes, auto circles and auto lines. Without that, it becomes quite tedious and not quite as efficient as it could be. So make sure you have Store Points and Feature Predict turned on prior to programming. So we're now going to look at building a very basic program. It is worth noting, to use the CAD software there is a separate tutorial series, so I'm not going to describe exactly every single step that I'm doing, so just be wary of that. But the goal of this is to use a manually added probe, build a program and show you how to run that through on the CMM. So the first thing is to bring the model in. I'm going to be using the Aberlink Test Piece New. So this is the small demo block that ships with every machine. And the first thing, I just need to set the visual alignment. So we're going to go here, set visual alignment, and that now knows where the X and Y axis are. I'm then going to go to the probe options here, and I'm going to select that 4x20 with the 20mm extension that I added manually. What I mean by that is I'm not using one of the probes that I imported from the CMM. So this is a manually added probe within CAD Probe Manager. If I then turn the probe on, I should get a visualization of the probe. That's it. And and I'm just going to build a very basic reference system. So this will be a plane on the top, circle on that center bow, and a line on this front face. I'll take some more measurements just to build up a bit more of a program. Maybe even drop in and measure one of these bows. So now we have that all written into the standard software. It's just a case of creating the dimensions. These are no different to using Aberlink3D in general. So here we go, and let's just line that up like so. So we've got a bunch of dimensions there, and all I'm going to do is go to inspection, save as, and save this as a program. So test piece from CAD. Typically you would save this onto a USB stick, or you can save it somewhere on the network where the CMM you are about to play it through on can also access it. This saves you from putting on a USB stick and transferring it over, but it will depend on your situation and setup. So I'll save that, and now we're going to look at running that through on the CMM. So we are now at the CMM, and the first thing we need to do is open the program. We can do this through the inspection toolbar and click on the open an inspection file icon and navigate it to your CMMX file that you created offline. It will also ask you to reference the CAD file. You don't need to do this to run the program, but it is useful to keep the link going with the CAD model in case you want to continue programming from CAD or want to do any CAD comparison. So I'm going to reference the step file as well. The next thing it needs to know is what material. So obviously this couldn't be done offline, but with the CMM running temperature compensation, it's useful to select the material, hit the green tick, and we are then ready to map probes and teach the position of the part. So the next stage we want to do is we want to click on the Open Inspection Program Details window icon, often referred to as Program Details. If we select this, the software will run a few analysis, so it will check to see if the probes used in the inspection are available on the CMM. If they are not, you'll see this message here. So some features in this inspection use probes that no longer exist. Do you want to choose a new probe for these features? The reason this message has been generated is we used the manually made probe in the offline package, and there's no probe on the CMM with that exact same name. So we're going to click yes, and that is going to take us directly to the probe mapper software. You'll see on the left hand side it has probes used in current program, and then on the right hand side we have available probes on this CMM. The idea is we left click on the offset in the left hand side, so that's the probes that's used in the current program, and then we left click on an option that we want to use as available probes on the CMM. The software does auto map angles. It does also highlight in bold a recommended probe that also suits the parameters of the probe used in the current program. As it happens, I'm going to use the 3x50 ceramic probe, and you'll see there it's automatically mapped an arrow. So anything in the program that uses this probe will now use this probe. You may have more than one probe, so just make sure all the arrows are mapped to the correct offset. Once that's complete, we'll hit the green tick. We are then ready to check the manually measure reference features box and also auto remeasure. So manually measure means we will use the joystick to manually teach the reference system. Auto remeasure then means it's going to run back in full on its own once it knows where that reference system is. So now we have these two checked. I'll hit the green tick and we are ready to then play the program. I'll just switch the camera on so you can see what's going on, and I'm going to press play. You'll see this if there's any dimensions in your program. It doesn't really matter at this stage whether we press yes or no, but it is a decision to consider if you want to save the data for SPC analysis. So I'm just going to click yes, and you'll see there we get a message box in the bottom right hand corner, measure the features manually until all reference features have been measured. So I'm going to now use the joystick, and I'm going to teach the 4 points on the top face you'll see the window starts to count the point down. Once we take the final point, the software will automatically jump onto the next feature, which is the circle. You can see it's highlighted green there on the screen. It's asking for 4 points. Again, as I take the points, they count down. And then finally the line on the front face. Once the final point is taken, the software will generate a message, so you'll see that here. The machine will run automatically after you press the OK button. Do any manual moves necessary to clear the component now. So we just need to be clear enough away from the safety cube. When we press OK, the software then goes, and you'll see it's now taking the points exactly where we took them when programming from CAD. It's still worth proving the program out, so just watch it all through. Make sure you're on the throttle to prove everything out, each feature, etc. But the idea is this is going to play exactly the same order and take the points in the exact same place that we did from CAD. You'll also notice now the dimensions update live. So because we had our dimensions set up with the correct nominal, tolerance, etc., all it's doing now is running the measurement and then assessing the dimension and generating the output. So there we go, that is now complete. We can save that as a proven program and continue to run it as many times as we need on the CMM.